Strange. Anyway, problem 4.9. Let's see. Chapter 04, problem 09. BST sequence. CLJ. Let's go to our templates. Excellent. And let's call it sequence. Sorry. And BST sequence. A binary search tree was created by traversing through an array from left to right and inserting each element. Given a binary search tree with distinct elements, print all possible arrays that could have led to this tree. Okay, and they have an example, which we could just put in our test. An array with 2 that contains the value 1 and 3. And they claim that the two arrays that could have led to this array are the arrays 2, 1, 3, and the arrays 2, 3, 1. Whoops. The array 2, 3, 1. Okay. This seems hard, but so basically they're saying if you built a binary search tree in the way they do, I guess, then the array 2, 1, 3 would generate 2, 1, 3, and 2, 3, 1 would generate the array 2, 1, 3 could generate this tree, and the array 2, 3, 1 could generate this tree. Just to make them slightly more visually distinct, let's actually just put it in the list. So, interesting. Or if we want to. I never really like lists that much. Let's put it in a set, I guess. They should be unique, right? So, we need to take the output tree and figure out what array could have generated it. Geez, I don't know what to say about this. So how do you build a binary search tree? Well, okay, am I getting min heap and binary search tree confused? I don't know. How do you build? I think I know how to insert and how to find, obviously, but how to insert and how to remove from a min heap. Okay, and I guess a max heap too, potentially. But how do you how do you build a binary search tree? I mean, this binary search tree, it's also a max heap, right? This one is. I mean, so a binary search tree is a binary tree in which every node fits a specific ordering property. All left descendants are less than or equal to n and are less than, which is less than all right descendants. So a min heap is not like that, because a min heap just says that all your children are greater than you, right? Because ultimately the root of the min heap should be the minimum. So a min heap is not a binary search tree. I don't really know about building a binary search tree, so let's look that up. I guess let's just think about it a little bit on our own and then look it up. How would you build a binary search tree? I have a sequence of integers, and I want to build what is the characteristics of a binary search tree? It's really the important thing is the left are all less than or equal to the node are all less than or, which is less than the right. So all elements to your right, or all children to your right, I should say. Well, I can tell you how to build it by brute force if. So let's pretend I just had 2. Let's just start off with a 2. All right, you say you've processed 2 so far. Your tree so far looks like 2. Right? Then you process 2, 1. Your tree so far, well, I'm not really getting anything terribly insightful here. But I guess you ask the question, well, is 1 less than 2? And yes, it is. Right? So you put the 1 to the left of 2, right? Then you have 2, 1, 3. And that means, whoops. Then you process your 2, your 1, and your 3. And that means you go 2. Yeah, you ask yourself, is 3 less than or equal to 1? Oh, less than or equal or greater than me. If it's less than or equal, I would insert to my left, but it's not. So instead, I insert to my right at 3. And I think I would just recurse this process, maybe. Now, this won't result in a balanced tree necessarily. Would, for instance, let's do 1, 2, 3. So 1 would result in 1. 2, 1, 2 would result in 1. I guess nil 2 actually. And 1, 2, 3 would result in 1, nil 2, which would then work. Now basically 3 is sitting here asking himself, am I less than or equal to, greater than or greater than 2? It says I'm greater than, okay. Right? So, I mean, that's obviously become unbalanced. We sort of need to pull the 3 up and rotate the 2 into the center position and all sorts of things. But what have we seen? I mean, I guess what we've seen. Well, one thing we've seen. Well, I don't know how you build a consistently balanced binary tree, right? It seems like you gotta like reshift all the time or something. But one thing we've seen is that the only point of let's just do the same thing the other way, right? So you got 2. Right, builds 2. Then we got 2, 1 or 2, 3, right? This guy would now build 2, nil 3, right? And then we have 2, 3, 1. This guy would build 2, 1, 1, 3, right? And so the interesting thing is we arrived at the same ending, but I mean that's that's pretty much what they said. But the only intermediary that was different was this point where it's not clear if you added the 1 first or the 3 first. Basically, there's no way to know. I think we do though. I guess actually know that you added the 2 first, right? And we actually know that, you know. So it's actually, is it the case that it's really just, I mean, maybe it's as simple as splitting, basically, you know? Like, if you have, so if I saw this, what would I know? If I saw this, what do I know? Actually, I know the exact order you added stuff in, right? Because I know you didn't go down this path, right, at all. And so that means you went down this path, and you didn't go down this path, which means you went down this path only, right? And this guy has no children at all, so you stop there. So I actually know this is the only thing that could lead to 1, 2, 3. I think. So there's something about that that lets me figure this out. So I feel like potentially it's just, you know, you are just splitting all the paths down, basically. In fact, I think this is really just, it's just the path of the position, right? It's just the path of your current position is all it is, right? That's how you built the tree, right? So, like, if you're too, well, no, it's not the path. Sorry, I misspoke. This one happens to be the path, but these two are not the path. But it is the case that it's the, so for each node, I think what I say is, okay, let's, you know, there's only two possibilities. Either you put the left one first or the right one first, right? And I can short circuit either of them if the other one is nil, right? So something kind of feels like if I take, not an excess, but if I take a root, right, and then I split it in two, I get the left and the right, right? I almost feel like it's probably maybe easier just to deal with this as an actual, you know, the left, right is our root. Now let's say some things, you know. I feel like this is another apply concat thing, right? Where basically I'm saying I want to look down the left side and I want to look down the right side. But I'm only going to look down. Well, I'm really not sure, so I'm going to say a cond right now. But if, oh, that's why we're doing condos, so we don't have to do that. But if both L and R, if both of them are nil, right, then we're done, right? We found a terminating condition. But I feel like we need an accumulator at this point. Okay. And I also feel like I think of the accumulator at the beginning is just going to be BST sequence recursive with the root and the empty vector, right? And so if it walks into here and it looks at this root and says, hey, there's no left and there's no right, right? Let's say, cool, I'm going to return, I think I'm just going to return the accumulation with myself added to the end, right? That should give you the correct answer for this case, right? Sorry, for just this case, right? You should be able to now pass this. 2 should return the, there's only one array that can do this, right? And that's the array containing 2. We don't quite do that yet, but I mean, that's fine. Oops. Made that up. Alright. Could not resolve symbol blah blah blah. Where did I put that? Oh, all of these are in the code. Don't know how to create iSeq from Java Lang long. Okay. So BST sequence root. Boom. Okay. Okay. BST sequence root. We're just passing in the root. And we're getting, not quite clear what's going wrong here. This guy just passes to this. I'm not really clear about this, so let's take it out. Okay. That's pretty close, yeah. So we did succeed in finding 1, right? We may need to do this at the top level too. I'm not really clear yet. But I mean, effectively, that's the simplest case, which is you have no left or right, so we return the accumulation plus your value, right? If, however, you have, let's just go through the permutations first. Why is this not lining up the way I expect it to? Oh, there you go. If, however, you have a nil left, but not a nil right, basically. So I guess we just need to check this. If you have a nil left, then we know which path you took, which was the right path. And so we only need to, it seems like we could write something better than this somehow. Somehow something that would sort of put all these together. Like, I feel like maybe sum as is what we want here, or sum thread. No, that's for nil. What I want is something that well, let's not make it too complicated. I mean, so if you have a nil left, right? Well, and let's just think if you have a nil right. All right, so now if you've gotten through all 3 of these, you actually know that both of them have values, right? And so the only possibility is that both children exist, right, at this point. All right, and so let's think. Or let's just be kind of silly. And let's return a vector out of this guy. Let's return a if we know that your left is nil, then that means you can only go down the right path, right? And so there's only a need to recurse on the right path, right? I think pretty much no matter what we do, actually, we're going to be doing this, right? So I think all we want to do is return new accumulator. I feel weird about... well, no, I want to make it consistent, so I am putting it in a sequence, even though it's a sequence of 1, right? For the top 3 of these, right? Because I'm going to go down 2 paths for this one. But this is BST sequence R with... so we need to go down the left and the right. I think yeah, so I think we just do the L. We do the R for the left. If the left is nil, we just need to walk down the right. And we're going to just pass in the new accumulator. Right? And similarly, if the R is nil, we're going to go down the left, pass in the new accumulator. And if both are nil, or if neither are nil is what I mean to say, we're going to go down both of them. The whole putting it into a... Okay, so whatever we get from this thing, we want it to be a sequence, right? Okay, so this puts everything in a sequence. But this means BST sequence is going to return a sequence of sequences, which makes me feel like we need to apply concat the whole thing. Because then our sequence of sequences just becomes a sequence. I don't know where I got that from. But we flattened it too much now. I just always find this confusing. Let's just do this. That's correct. Actually, I thought that would be equal. Oh, I guess it's not equal because sets care about order, or sets don't care about order. Well, I was being silly. That's not going to work. Nope. Let's just stop being silly. Do that. That's fine. Okay. So, what about the next one? Okay, so it kind of got... It didn't actually... First of all, it's not the right... Well, first of all, it's like sequence within a sequence within a path, you know? But ignoring that, it's also... not doing the third call. And it's not flipping. So there's just all sorts of problems with that. Before we get to this one, let's just do one slightly more complicated and say 2-1. Actually, that's not a BST if we do that. No, it is, sorry. 2-1. Is there any other possibility it could generate this? I don't think so, right? That's it, right? So let's just get these silly things at the right place. So what does BST sequence return? BST sequence is going to return a sequence of accumulations. Now maybe the last one, when you're actually done, doesn't need to be an array. No. So how did that happen? How did you lose? Well, I think this tried and true solution to this problem is do this, do this, do this, and I think that's pretty much all we need. Alright. Oh, and stop doing this. Alright. So we came in with 2, 1, and the empty accumulation. We then went to 1 with the 2 accumulated. The 1 should pass this one, which I think it did. But the funny thing is, it didn't put the... didn't put the 1 on the end. Why didn't it do that? Just, okay, sanity check this. This should be the new accumulation, right? I guess let's put this out of the argument position. Yeah, so 2, 1. Right, why didn't it return 2, 1? Why did it return something else? Why did it return something else? Not quite clear. It certainly would have passed this one, right? Nil of L and nil of R. I mean, just to be crazy. Let's just put in what we actually destructured to. Yeah, 1, 0, 0. So we definitely have a nil of L and a nil of R. And so we should have returned new accumulation, which should be 2, 1. Oh, it did work. Did something not work here? Oh, this guy stopped working. It's not this one that's failing, it's this one that's failing. That's because it's too flat. Ugh, yeah. I hate these flat things. I need to figure out the pattern here that I'm supposed to be using in general for this kind of stuff. Value left, right. New accumulation, const, accumulate V. And nil left and nil right. So we can get the right answer out, which is 2, 1. But it's kind of confused in that... Alright, why does this not return the right answer? Because we pulled 2, 0, 0 out. And it returns 2, but 2 is not. Yeah, so I'm fairly sure we actually do need to return this as a sequence 2. That's correct-ish. Well, damn. I mean, like, the obvious solution is just double bracketed, but that seems weird. I can't understand why you'd need to do that. That kind of stuff it just seems mysterious why that works. Anyway, let's try the other one. 2, 3 with a nil. Right, the only way that this could have occurred is 2, 3. Okay. What about 2, 1, 3? Failure. Alright, but at least our answers are seemingly... Well, no, why should I say anything? So we started at 2, 1, 3. Then we recurse presumably down the left side. Oh, I think yeah, I can see it. So now we're at least recurring down the right direction. And we're calling the BST sequence with 1, 2, 3, 2. Wait a minute, that doesn't seem right at all. What? I'm making this too complicated by putting in all this stuff. Roots. And I can figure this out just by looking at it. Alright, so. I'm gonna actually put the values in here. Okay. So root is 213. Then it became root is 1 and root is 3. Accumulation was 2 and 2 for both of them. New accumulation is 2, 1 and 2, 3. Looking at the root, should definitely be the case that you exit here. Right? We're going to return the whole thing. But somehow it doesn't contain the 3. That's weird. That doesn't make any sense to me. I can see the... Wait a minute, no I can't. Well, 2, 1, 2, 3, yeah, and that's what we returned, yeah. But it actually short-circuited already. Wait, maybe that is the right answer. Let me think about this. Oh, I'm just dumb. Yeah, I'm just dumb. It is the right answer. Wait. No, it's not. No, it's not. Which one is this going down, actually? It should be going down both of these. Oh. Oh. I see, yeah. Well, I mean, I am doing exactly what I said I should do, but it's not right, actually. I was confused about something. We're just throwing away the... I mean, in this case, you happen to be right, you know? So I think maybe this last one would actually work. Let's see. Alright. But then, and this should only have one possibility. Let's see. Bad. Good. Okay, so we got all but the actual important case passing at this point. What we don't have passing is this one, and that's because it's basically just entirely discarded the path it had to take down 1. Sorry, the path it had to take on the way down on 1. Jeez, how do I do that? How do I thread the two together? I'm saying here that you have a left and a right. Does that mean... So the new accumulator is definitely, because you entered this one, the new accumulator is definitely, it's added your V into the front. But does this also mean I would add the first and L to the front? I'm not sure. Let's give it a shot. I just don't know. I can't reason it. So if you're going down the left, then we should add the first to the right to the new accumulator, right? And if you're going down the right, then we should add the first and left to the new accumulator. Ooh, yeah, no, by that I mean the first of right. And I mean the first of left. This may just be because... Actually, they are better as sets, because they really are sets, so we should do that. But we just should convert the other one to a set too. So 213231. That's fine. Yeah, this is just too hard to read. I'm gonna change it out a bit. Put it into a set. That's at least visually distinct. Set. A set of 1. And a set of 1. Okay, and then what I'm also going to do is convert this guy into a set. Just so that they're equal. Whoa. Okay, that's kind of cool. And let's just look at the last one and see that visually seems like it's doing reasonable computation. So it starts at 2, 1, 3, right? And then it says, okay, I know I'm going to be going, or here's what I have left, and I know I'm going to be going down 2 and 3, right? And I know I'm going to be going down 2 and 1. Right, this is what was passed into the function. And because of the fact, actually I'm not quite clear about that. Shouldn't there be another level of recursion here? 2, 1, 3 split itself in 2, right? It said, okay, I'm none of these first three cases, and I'm actually the last case. So I'm going to go down both paths, and that's let's do our little trick here where we can apply string to the take of the count of the accumulation on the empty string, and then now I can get a little indentation, maybe double space, just to give it some oomph. All right, so I'm recursing from here to there. 1, 2, 3. So far I've accumulated 2 and 3 and 2 and 1 by going 2. And it is interesting, yeah, it went from an accumulation of empty to a double accumulation, and that's because it took the left path already. I'm just not clear whether this will work all the way down. I think it's a good start, you know. But I guess if every node is behaving on this, like these are all the possibilities that could exist, right? So I think it might work, but it seems weird to me that it skipped over like there was no accumulation, but there was just one value in there, the 2, you know. But why is that? Well, because you went down both paths. But then why don't you do that in the general case? Well, for instance, this one should only match the third one, right? Yeah, it does 3 separate calls into, I believe, nil left, so this guy, right? Or 2, I mean to say. And he builds up one at a time. First he's the empty accumulator, then he's the 1 accumulator, then he's the 1, 2 accumulator. How do we build the reverse of that? I guess we just do 3, 2, 1, right? 3, 2, 1. And now everybody is the first element rather than the last element. Okay. Okay. So that seems to kind of work. I'm a little bit weirded out by the fact that this guy just suddenly accumulates with 2. You know? He goes from 0 to 2. Like, I'm worried that we're skipping something. But I guess if I know you have children, then there's no need There's no need to... If I know you have children, there's no need to deal with this for some reason. This is also this wigs me out, right? New accumulator is a vector, in a vector, in a vector. Why does that need to be? Well, at this point, I would have submitted my solution, and I would say I'm done. But let's be honest about it and actually look at something that might break it, you know? 2, 1. All right, it's hard to think about these things since 3, 2, 1, right? That should be a valid one. But we also have the other side. We have 4. Actually, that's not true. Right? I'm not sure what this will return. Let's see. I'll comment most of these out. Alright, so it says you could get there. Well, this has to be incorrect, right? You could have entered 3, and then 2, and then 4. That obviously cannot be right, right? Or you have to enter 3, and then 4, put it to the right, you know, and you still are nil here. And then 2, put it to the left, that's okay. And then 1, put it to the left. That makes sense. How come this isn't working? 3, 2, 4, 1. 3, 2, 4, 1. 3, 2, 4, 1. So let's look at that. Somebody was able to really jump ahead here. So it's got to be this guy, right? 3, 2, 4. What happened to 1? Well, he doesn't get to see it because that's on the other side. God dang it, this whole thing doesn't work. 3, 2, 4, 1. It's like it needs to zip the two possibilities together. Right, because the guy who's walking down this path, the 324 path, 324 path is down the 4 path, right? And that's now empty. But actually the 1 came in at some point, you know? Three, two, four, 1. The 1 did come in at some point. But 324 is not on the subtree that knows about the 1. So it's almost like I just don't quite see it, honestly. So it was a neat idea, but it's not correct. If only I hadn't bothered to see the folly of my ways. It's like these can't be independent, right? Like I'm independently splitting them and just walking down separate paths, so that can't really work. It's like I'm just taking the first R, but there's actually... Ugh. Yeah. It's got to be more than just the first of the R. You're ignoring the fact that you can have recursion on the left side, too. Or you can have things that factor into the left side as well. And this works up to depth 1, you know. Maybe even 2, I don't know, but it's not going to work generically. Lame. Alright, well, something to read about this evening. I'll just read the hints to see if that gives me something to think about while I'm, whatever. 4-9, BST sequence. Number 39, number 40, okay. So the hints are... Number 39 is, what is the very first value that must be in each array? The root of the tree. I think we captured that with the accumulation. I got it. Okay. Number 48. The root is the very first value that must be in every array. What can you say about the order of the value in the left subtree as compared to the value in the right subtree? Do the left subtree values need to be inserted before the right subtree? I don't think so. Do they? I don't think so, dude. 2, 1, 3, 2, 3, 1. I don't believe that's true, is it? I don't know. 66. The relationship between the left subtree values and the right subtree values is essentially anything. The left subtree values could be inserted before the right subtree or the reverse. Right values before left or any other ordering. Yes, okay. So you said the answer is no. 82. Break this down into subproblems. Use recursion. If you had all possible sequences in the left subtree and the right subtree, how would you create all possible sequences for the entire tree? Yeah, I mean, I think we'd get there. Okay, so that doesn't really help anything. I mean, I see the error, but it's like I need to... I think I maybe don't need an accumulator. I think the accumulator actually kind of makes it harder. You should just be returning... You should just be returning the trees... You should just be returning the array for your trees. Ugh. You should only be returning a list of arrays necessary to build your node, which sounds like the same thing I'm doing here, but it's like, I guess it's bottoms up instead of tops down. It's some it's an overused term, overloaded term now, but it's like Alright, let's try to do it the other way. I guess that did give me some thought in the sense that it's making me think, why don't we try doing this from the bottom rather than the top? Kind of thing. So what if we wanted to start from the bottom? Let's just, well, I think this is still true, this top part. But let's not be doing this. We don't want to build an accumulation at all. In fact, we just want to keep splitting the thing until we get to a root that has no children. Basically, that's the terminal. That's the one we can't solve for. Right? If you're at a root that only has one child, I mean to say, not no children, but only has one child, then and you can just return v, right? In fact, it should be such that thing with no children should actually just be the root, if the thing is properly structured, you know? Okay, if you have no children, then that is the sequence, and that is, you know, the trivial one we solved right here. But actually, is it that, or is it a sequence with your root in it? Yeah, everything needs to return a sequence with your root in it. I agree, there is no accumulation anymore. We will miss it. Oh, I deleted my finger on mistake. Okay. What if you're the one element root? What if you're a root element that is not like that? I just don't know. I find it very complicated to think about even. Okay, so we do know that first one, right? If your left and your right are both nil, then you're probably done. Let's put that back actually. I'm not clear about the apply anymore, but if your left is nil and your right is nil, then you're done, you know? Your tree happens to also be the array of values, you know? But if your left is nil, or, and you know, maybe we can just do all of them, right? If v is nil, right, which means like that this is just a dull terminal, then we're going to return the empty array, right? If L and R are nil, then you can return the root. I'm just going to return the v, actually, or sorry, return the v. That's the only sequence that can lead to this. If you have nothing in here, does that even make sense? Well, I kind of like it because then maybe I won't need to do separate processing. I can just treat it generically. But of course, that will mean that you'll have duplicates, right? You need to ask the BST sequence, what are your children? But I kind of need to have both of them be propagated already, so I just don't know about this. Okay. And BST sequence recursive. So if I have the left subsequence and the right sub, just presume that I do have them, right? I have all the different ways the left subsequence could be built and the right subsequence could be built. Then what do I need to do to those to add myself, right? Well, I'm just those things plus, actually, yeah, this is actually the list of this is nil, let's say. So nil returns literally nil. It's too long a word to spell every time. All right. Is it n squared possibilities? That seems reasonable-ish, right? But it's not quite n squared. It's not a for loop and a for loop is what I'm saying. Because that would mean that if any of them were nil, well, it is kind of a for loop with a for loop. But yeah, that's why nil actually does return nil, right? Because it needs to return a value. Man, does it actually return nil? Oh my gosh. So V is nil. Do you really return nil? That seems weird. Should you ever be in here? It should never happen from the root, right? You shouldn't be passing in nil as the root. This maybe could happen as you recurse, if you're blind like I am, and you just recurse without asking, does this, the L or the R might be nil, right? So if you recurse on nil, this nil could come in, And if you do that, it should return nil. Okay, so I think that does actually make sense. But what if V is not nil, but L and R are both nil? I'd prefer that we just not go into nil. I prefer that BST subsequence rec L should only go when L and when R BST subsequent sequence rec R. So this will end up being nil anyway, but just in a different way, right? And if we do that, I'm going to define leaf as being a node where basically this right here. Ignoring the V, I'm taking the L, I'm taking the R. Screw it, doesn't really help me understanding too much. Or does it? If we're at a leaf, then on the root, right? Then it's time to just return the value at root. I don't like that, that's stupid. Let's just take that. If we're here, if L and R are basically a leaf, then return the value at the root. That is the only way. It's a sequence of a list. That is the only way that that can be true. Otherwise, we're going to have to recurse. We're going to try not to worry about whether the L or the R exist or not. But if they don't exist, they're going to be empty. So if they don't exist, they're going to be empty. Which means that if we do double for loops, we're just going to end up with it's almost like the probabilistic OR, and it's like you need the probability of A plus the probability of B minus the probability of A and B or something like that, I forget. Is there overcounting? Or maybe they're not double for loops. Maybe they're 2 for loops, is what it really is. But no, they need to interact with each other. But there's no. I feel like it's like a for. Jeez, I just don't know. They need to have run independently in terms of what they could generate, right? Let's just pretend they both just generate. Both of these things end up returning this, right? A sequence with one item in it, right? A sequence with a list with one item in it. Right? If that's the case, then I take that one item and a sequence with a list of one item, and I mean, these two guys ran independently. They're literally unaware of the other node, right? They are unaffected by the other node, for that matter. So, regardless of what happens, they need to be interleaved in every way that they can be interleaved. No. They need to be interleaved in every way that they can be interleaved. Which I think sounds like a for loop within a for loop. Now what happens if one of these is nil? Then if the nil's on the outer for loop, it's just not going to loop at all. The nil's on the inner for loop, it's going to loop on the outer one, but then the inner one's going to be nil, which is going to cause nothing to happen. But they're... But I think I don't want to handle this. This is just too hard to handle that way. So I'm going to do this, and then I'm going to do just like I had before, but a little bit different. So if the left is nil, we're just going to go down the right path. If the right is nil, we're just going to go down the left path. And that is correct. Right now, I'm not clear whether we need to, again, put this in another vector or not. But then we do know that both of these are not nil, which means we just need to take the permutation of all of them. And let's just pretend that the left subsequence and the right subsequence are like this one right here, and that this one right here, and that they both contain one item. And so they both return a vector of size, a list of size 1, you know? Is that what they contain? Because it looks like they either need to be returning a list of size 2 and we conj 1 onto the top, which seems to be the logical thing to do from the bottom up, or they need to have already accumulated 2, 1 and conj the 3 at the bottom, which is, I think, the way we did it before. Right subsequence, left subsequence. All right, so now I don't think we need to worry about this anymore. We don't need to consider the possibility of what if they're you know, nil, right? They'll always have at least one value in the right subsequence, which I suspect means that we do need to do this still. We're probably going to need to do the apply concat thing too. But we did independently compute these two things, but now we need to sort of put them together. Okay, we got them independently. Does it matter which order? Does it matter who's on the outer for loop and on the inner for loop? All right, so let's just write stuff down, because I'm just sitting here thinking, but it's not resulting in anything happening. So it's actually a better name, but better. You know, actually, I forgot. I think you can actually do this with a single for loop. There is an advantage, I think, to do it. You know, I don't even think there is. You know, I kind of forgot that you can do a for loop like that. So Yeah, you can. Okay. I don't... And I think each of these is only calculated once, is my guess. But I guess it doesn't matter. But it's mutable language. But we'll figure it out anyway. Okay. So this is a for loop, right? And so what are we doing with this? Well, there's no implied order here. I don't think. So if we returned, if BST sequence rec L returned the value 3, and BST sequence rec R on the node 1 of vector 1 returned the value 1, then we now have a 3 and a 1. What do we need to do to make it into something useful? Well, it feels like we should only be consing we gotta cons the other one. So one of them is 3 and one of them is 1. So we need to end up with 1, 3 and 1, 1. And ultimately we need to end up with something like cons of V of... See, I just don't get it. But we need like every permutation of these two things. So how the hell do we do that? How do we do that? How do we... I mean, these have to be independent, right? Because these are separate paths, you know? They're completely separate nodes, so they are independent of each other, which means... Can we just concat the two together or something? I'm not quite clear. Concat the value with the left sequence with the right sequence. What does that do? See, it's also the other way around. It's also concat the value with the right sequence with the left sequence, right? They're equivalent. It shouldn't all. Basically, what I'm saying is that it shouldn't always be the left sequence occurs before the right sequence. It should actually also be the other way too. So, you know, basically 2, 1, 3, 2, 3, 1. They're both valid, you know. But then I need to sort of return a single thing because it's just currently going to just return the last one. Boy, this just looks just freaking ridiculous. So 2, 1, 3, 2, 3, 1 will itself... I don't want to concat it, actually. I don't think. 2, 1, 3, 2, 3, 1. Maybe I just want to return it as a list here. So it does return the whole thing. But then I do kind of want to concat the whole thing. Right, so this is a vector of list, right? This is a list. This is a vector. This is a lazy sequence. I kind of want to concat that, I think. So maybe I don't need this, but I do kind of need to... I mean, this guy's returning a vector of a list, right? This guy's returning ultimately a vector of a list. This guy's returning a vector of a list. So it feels like this guy needs to return a vector of a... Okay, so what is it really returning? It's returning a vector of arrays, right? There happens to only be one array in here. This is returning a vector of arrays. This is returning a vector of arrays. This needs to return a vector of arrays, whatever it does. It currently returns a vector of arrays right here, but then it's put in a sequence. So I think maybe this thing needs to be... That'll just leave it the... Wait, no. So I'm basically undoing this for loop, or moreover, I'm putting all these little vectors. This is a sequence of vectors of arrays. So if I apply concat to the sequence of vectors of arrays, then it should just be the sequence of arrays, or whatever, you know? So everybody's returning, at minimum, a sequence of arrays. Sequence of arrays, right, when you're literally a leaf node. Sequence of arrays when we're just going down the left path. Sequence of arrays when we're just going down the right path. Other way around, actually. This is a sequence of arrays returned in a sequence, but then I apply concat on the top sequence to bring it down to just a sequence of arrays, just like everybody else. Let's see what I've done. Alright, could not resolve symbol L. Line 20. We don't need this at all. Cond requires even number of forms, fair enough. So that's not very impressive. Fuck, already broken. Alright, so you got 2, 1. You then went down to 1. You ended up with just 1. God dang, this is hard. And that is... So it went down to 2, 1. It ended up returning 1. But it kind of lost its 2. How does it even lose the 2? The 2's right there. Well, no, it wouldn't have actually gone down this path. It would have gone down this path. But yeah, this guy has nothing about putting the 2 back at the front, which seems like an error. Maybe this whole con thing should only be responsible for building up. I mean, this guy is responsible for returning this node's list. This guy is responsible for returning the children of this node's list. Or the things that are underneath this node. This guy's responsible for things that are underneath this node. I'm kind of thinking maybe we can just cons the V onto the top of the whole thing. Not deal with, like this guy will now return nil, right? This guy will return this guy will return this. This guy will now return. Actually, he needs to return a sequence, not a R and an L. I mean, technically, this is a sequence. This and this are also returning sequences, and that if they, eventually they got to go into one of two places. Either A, they are a leaf node, in which case they'll return nil, but then they'll cons their V on top of them, which would mean they're returning a sequence. Everybody's returning a sequence now, because everybody's consing a V onto the end of the thing. I don't think we can do this, actually. Because this guy needs to map the V's onto it. So maybe not. That does make me think maybe we can use mapcat. And the thing we do is we're just going to cons the V onto every single one. Right. And now we don't need this. In fact, I think we can probably just into both of them. No. This guy's still going down this path. Yeah, well, we still have the same issue, actually. It's just that, like, this guy cons his V on this way. Yeah, everybody does return a sequence. So I don't think... So what about... What's the difference between mapcat identity and apply concat? I don't think anything. Right? But okay, now everybody's... When they go down this path, they're going to just return the thing, but it doesn't have the cons on it, right? This guy doesn't have his cons on either. This guy does implicitly have his cons on, but I think we can actually just return nil. And now I feel like we can mapcat at the top the cons blank onto whatever, cons V onto whatever you return, right? And whatever you're going to return, we're going to... So this guy returns a sequence. This guy returns... a sequence, maybe? This guy returns a sequence. I mean, you can't do this permanently, right? You eventually have to either hit a leaf node... Well, eventually you have to hit a leaf node no matter what, right? And eventually you'll return nil. Okay. I think it's actually just one word. Mapcat cons. But this BST sequence is, if it returns nil, if it returns nil, then it will not process anything. It actually needs to return nil, oddly enough. Right? Because nil, this is indicating that you are a leaf node, right? And so cons V will now cons onto V nil, which is the same as just writing list V. Weird. Don't know how to create IC from Java lang long. Probably coming out of here. going to do something a bit weird here. I'm going to say print line return is equal to return times return. So this guy did hit this thing. He's hit the nil, right? And he's like, cool. I'm going to put v onto nil. That should return the empty list, which is what actually you can look at the next guy, right? That's what he got. The empty list. But I see he's trying to put no, actually I'm not quite clear what he's trying to do. Presumably he ran down this one, right? So he got okay. So I think these guys still do need this. That seems weird. But it's not weird because it's going to map cat the whole thing. This is going to, whatever comes out of BST sequence is going to be a flat sequence of list, right? Whatever comes out. But mapcat needs to put himself on top of every single one. I'm not even clear if this needs to exist anymore. No, it does. I'm going to change it back to now we got son of a gun. Fuck it, this is too clever by half. Let's just... Alright. I vaguely understood the code when we did this. Alright, okay. And then, fine, these guys want to be punks, that's fine. BST sequence is ultimately always going to return a list of a sequence of, let's give them names, a sequence of paths, I guess, right? And so we're going to need to put the V on top of everything. Just the annoying thing, if that's true, then why is this so... Why doesn't that work? Still don't see it, honestly. We need to put the cons on top of everything. Okay, that makes sense for this. I think that makes sense for this. Does it? BST sequence should always return a list of arrays. Let's just call them arrays, okay? So this is going to be an array. It's going to be a list of arrays, right? In fact, if you do this one, it's only because nil is the only value in this sequence. It's going to map cat over that nil and return just the list of an array, you know? This is doing the same thing for right and for left independently. It sure looks weird that we actually have to do this twice. I don't quite get that. I guess maybe we kind of don't, because Let's not get clever here. BST sequence rec R, BST sequence rec L. Good lord. Nil L, nil R, nil. L sequence, BST sequence rec L, BST sequence rec R. Into L sequence, put the R sequence. Into the R sequence, put the L sequence. Print line return. This BST sequence should return, which is right. Okay. Do not create I sequence traveling along. I'll believe it because this is returning a thing. I just don't get why that. Okay. But now I've fully flattened out the whole thing. It may actually be in the right order. It may just be that the set has reordered it as I put them in. But ignoring that, why is it that flattened? This guy should just be adding the V to every item in the sequence. To every array. It should be adding V to every array in the sequence. Whatever that sequence might be. I mean, I think he's adding the V correctly to this one, you know? Okay. I don't think he's adding the V directly to this one, but like my solution is just dumb. Just double up on the... No. Kind of, but no. Let's not convert it into an array, because that's our set that's making it confusing. Alright, so 2, 1. That was my claim, but we flattened it too much. It was okay here, right? Because it started at 1. Actually, how did it end up here? We started at 2, 1. So we had V as 2 and 1 as the L. We then recursed into 1. That is the nil L nil R case. We returned nil, which became the return of 1, right? And yeah, the return of 1. And then we should have cons on top of that to get 2, 1, which we did. But then why did we concat the whole thing? I don't quite see that. Maybe I don't understand what mapcat does. So for each item in the sequence, it'll apply the function, and then it'll concat the whole thing. So I think it's strictly equivalent to just doing a map first, to taking a sequence, running the map of reverse on it, and then running the concat of that. Actually, the apply of concat. Two on, two on, two on. Whoa, it's so hot today. It's ridiculous. Two on. All right. Alright, let's just try map and then concat, which isn't the same as apply of concat. Well, first of all, let's just do map, just see what happens. So that's kind of weird, right? But kind of makes sense. Now let's try doing the concat of that. Makes no difference. Back to this. God dang it. There's something weird about this. We're going down the right path now. That makes sense. It feels like maybe we need another one here or something. No, I'm just not clear. Doesn't make sense to do that. What is it literally returning? It's literally returning this. And then we're saying, okay, cons onto that. So that should give us 2, 1, and it does. So now we have a list of arrays, but then we destroy it by doing this. Oh, must have been off. I guess not. It's just a weird way to. Why would it take the whole thing? Whoops. Screw that up somehow. Oh, I just screwed it up before it's back to hell up. Okay, what am I doing wrong here? I'm copying everything out of this. Then I'm going to copy this into here. Copy this out. And I'm going to copy this into... Actually, I guess I'm just going to copy this. Copy this. This is the return. Oops, this is the return. Then return. Oops. Okay. So originally returned a sequence is one that it seems weird, but I actually think that's maybe right. You're saying somebody called into BST sequence and you're saying, hey, the only array that could have come out of here is this array. And that's actually, I think, correct. But then when you try to start building things, you seem to have consed onto the list itself, not... You've consed onto the list of the list, not onto the list. When you look at this, I think. Closer. What did I do that's different? I don't... You've consed onto the list of the list. And here's where the first one that actually requires that third thing comes in. You go on root, return this? Really? How did you get there that fast? Oh, because now it's printing afterwards. That's confusing. Let's do... this. Fortunately, we lost our cool little putting a different indentation things. So maybe we could just sort of count it. 2, 1, 3, 1 returns 1, and 2, 1, 3 whoa. What? Is that it? What? Oh, I think it's like it doesn't actually evaluate it until you need it, and so it kind of mixes the stuff together. That sucks. Okay. 2, 1, 3, 1. 1 returns 1. 3 returns 3. 2, 3, 1. 3. Oh my gosh, just completely fucked up. All right. I tried to put it, not even clear. I tried to put the 2 in front of the 3, 1 and the 1, 3 vector. But so many things with that I just don't quite get. Why? We need to flatten this out somehow. Why do I do this twice? I don't quite get it. Cute. But I'm still not convinced. Cute. Now, what was the thing? I wish I hadn't erased the thing that failed. Oh, son of a gun. Let's just try to think of something that should fail. I think we went up to 4 and it already failed there, so let's try like 3, 2, 1. I think in 4 was maybe what we did. So you're telling me the only way to build that is from 3, 1, 2, 4. Is that true? What about 3, 4, 2, 1? Oh, it's there too, actually. Kind of seems like this might be correct, but I don't know. I mean, I don't know. Does that seem reasonable? Let's make sure this. All right. I mean, let's just clean this up a bit. Clean. Where's my V? There it is. Clean this up a bit. So we don't need this anymore. We don't need this anymore. Jesus. So I don't like this code. Something about it is just missing. I think that oddly enough, the most clarifying thing was to write the documents or the function string right here, so I could keep in my mind what the hell this thing is supposed to be returning. You know what I should have done, and what I should do in the future with these type of problems is write a precondition, right? Like this has to return a sequence and the sequence has to be made up of sequences, of 0 or more sequences. Well, no, actually 1 or more sequences that are all logs or all numbers, right? That's the starting point, right? If you start with the whole like it has to return a sequence of 1 or more sequences that are numbers, right? Then at least you can get all the like weird apply concat blah 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 stuff out of the way. Okay, so just to all right, so we have a working copy of this, right? But I actually think when I look at this, that we can maybe not do this, make this into a sequence, make this into a double sequence, and maybe mapcat this one. Nope. Nope. Just trying random things at this point. Yeah, no, that's not it either. Okay, so I had not a huge amount of certain about the double sequence thing. Maybe that was wrong. Yep. Oh, screw it. Yeah. Golly, it's so hard to reason about what you have at each level. But yeah, I think that's one of the big take homes on this one is write a precondition, or a postcondition actually, just so you know that you're returning the type of thing you expect to return, right? Because it's just super easy to get confused about that. It's like if you can just write the postcondition, then you can just stop worrying about it, right? You can just I know that's true, right? And you can correct that the moment you start going wrong on that one, because I feel like that's partially where I spent the majority of my problems, just figuring out how to put and part these sequence things, you know, where I need to concat and where I need to. Why is this such a common pattern? Why, if concat needs to be used in that way, why do people always call apply concat? Why doesn't concat? I mean, strictly speaking, all concat does. Let's make sure I don't misquote this. You know. All concat does is take sequences and oh, you know what? I am takes sequences and concatenates them together. Into a single sequence. So I'm going to visualize it as it takes the first thing and it just takes a little piece of string, connects it to the next thing, a little piece of string, connects it to the next thing, and that's it, right? Apply concat, though, takes a sequence of sequences and keeps them separated. Or apply concat on a sequence of sequences. I wish they hadn't put these in. But a sequence of sequences, a sequence of sequences just results in a sequence. Apply concat on a sequence of sequences of values just results in a sequence of values. Yeah, just somehow it's just confusing to me when I do it. Apply concat on a sequence of sequences of values, these things, results in a sequence of values. Okay. This returns a sequence of values, arrays in this case. This returns a sequence of values. This returns a sequence, the vector of values, the v applied to the nil, or constant to the nil. So everybody is returning a sequence of values, which is really a sequence of arrays in this case. Yeah, it makes sense. It's just I think this is kind of cute, honestly. You know, now everybody handles it the same way. That's kind of nice. Everybody, and it makes it, I mean, if you think about it, it makes it a little bit clear that like all that each segment is doing is really just consing v onto the sequence of values, right? This is a bit wonky to think about. I wouldn't fully reason my way through it, honestly. I think I could only explore my way through it. But it seems like it maybe works. I guess let's try going worse. 5, 2, 1. Whoops. Okay. Really? So there's only one way that could have occurred. 3, 1, 2, 4, 5. So you put in the 3. That doesn't even look like a right answer to me. Wait, how is 1 there? God damn it, that's not even right. 3, you insert the 1. It should be 3, 2, 1, 4, I think. Right? Three, 2, 1, 4. 3, 4, 2, 1. Is it? Do they need to be reversed? Oi. Do they need to be reversed because we're intuing them? I am not sure. You're intuing on a sequence. I don't believe this is the right answer. I think this would give 3, 1. I don't think that would give that. I do think this is the right answer, actually, but I don't think this is. So just out of curiosity, I'm going to just try kind of reversing the polarity on these. I don't know why I'm doing this. I kind of feel better about that. 3, 4, 2, 1. I see, I see, and I think you're right. 3, 4 on the right. Then you put in the 2. Then you put in the 1. That makes total sense. 3, 2, 1, 4. You put in the 3, then the 2, then the 1, and then the 4. And then What about this one? Okay. So I'm claiming that 3, 4, 5, 2, 1 is a valid solution. 3, 4, 5, 2, 1 is a valid solution. I'm also claiming that 3, 2, 1, 4, 5 is valid. 3, 2, 1, 4, 5 is valid. That seems reasonable. But what about 3, 2, 4, 1, 5? God damn it, it still isn't right. Oh, okay, I give up on this problem. This is just ridiculous. I don't know how to do this. All right, we are about to. We just hit the 2-hour mark. It's done. Yeah. Or at least on this stream. All right. I guess we can copy this one because I think it is. It does happen to be the right one, but it's only coincidence. 3, 4, 2, 1, and 3, 2, 1, 4. Let's just see if there's other. We need to do 3 and then 4. Wait a minute. Let's just make sure I'm not getting angry about nothing. 3, 4, 5, 2, 1. So you put in 3 and then you put in a 4. And then you put in a 5. You put in a 2 and then you put in a 1. It's like rather than just. It's like you need to zip them together or something. I'm not clear. Yeah. 3, 4, 5, 2. I do think it's returning valid solutions, but I don't think it's returning null solutions. Or for that matter, 3, 4. Three, 2, so I've already pulled the 3 and I already pulled the 2. Then I insert the 2, then I insert the 4, I insert the 1, then I insert the 5. Maybe something's wrong because I did this weird thing. Am I doing something dumb here? Oh wait, the nil does limit this, I think. It had to be, the 5 had to be inserted after the 4, right? Well, duh. Okay. 5 had to be inserted after the 4. Not only because it's a child of it, right? But also, well, that's about it, really. So as long as the 5 is inserted after the 4, that's fine. Three, 2, 4. Yeah, I just don't get how to get all of these. I think I kind of thought if we had all the permutations, but we don't have all the permutations. That's the problem. We're missing some. But it seems like we have them for the, maybe, oh, well, maybe we should try for the, we got it for this. That's the no children. We got it for this. 2 and 1, right? We got it for this, 2 and 3. We never did it for, well, this one really should be the next one. There's no way of knowing which way you did that. But 2, 1, 3 or 2, 3, 1. Right? 2 0, 3, 2, 3, 1 0. Nil 3. That'd be 2 3. Yeah, pretty much the only thing. 3 2 1 is 3 2 1. It's the opposite of 3 2 1 4. We're missing one here too, aren't we? Also missing 3 2 4 1. Alright. Is that all we're missing? You have to start with 3. Alright, we're okay on that. Then you can go 4 first, or you can go 2 first. Okay, if you did 4, you can go 2 1, and that's about it. If you go 2 first, you can then put in your 1, or you can then put in your 4. Or, sorry, put in your 1 or put in your 4. Then finally you got to do the last thing. This just doesn't work any better than the last solution. Damn it. Yeah. I spent enough time on this. It's time to go shop on this. Alright, oops, GS, stage, commit, that's disappointing. BST sequence, problem 048. Or 8 in fact, in every 6th edition. I did not solve this correctly. Wow. Alright. Cool. Alright, that's more success than I usually have in a single day. What time is it? Wow, we're not even noon yet. Well, who knows? Maybe if I feel the inclination, I will do a problem from chapter 16. But, yeah. Okay. That's it for now. I gotta take care of other things.